Bismillahirrahmanirrahim. In this tutorial, I am going to discuss series parallel connected resistive networks, how to figure out equivalent resistance of these networks. In this example, you can see R1 is neither in parallel with R2 nor in series with. Similarly, R4 is neither in parallel with R3 and any other resistor. First of all, I would like to tell you these type of circuits are easily solved by practicing them, and there are no hard and fast rule for solving these type of circuit. So let's begin practicing. As you can see, resistor R5 and R6 are connected between the same two nodes, that is node 3 and node 2. This is a single node. In between these two resistors are connected, that is node 3 and node 2. So R5 and R6 are parallel to each other. So after solving with equivalent formula, we get R9, which is equal to 10 ohm. R5 is in parallel with R6 and R9 is the equivalent resistance of these two resistors, and R9 is equal to 10 ohm. So we can replace these two resistors R5 and R6 with a single resistor which I called R9, and it is equal to 10 ohm, and it will be like this, and we eliminate these two resistors R5 and R6 and replace them with a single resistor R9. Let's move forward. I redraw the circuit, and in here you can see R3 is connected to this node because previously it is connected to the same node. You cannot change the position of any resistor like this. You can see R3 is connected to this bottom node. Now you can see R4 and R9 are in series with each other, and the equivalent is simply 30 ohms. So R4 is in series with R9 and R10 is the equivalent resistance of these two resistors, and R10 is equal to 30. We can replace R4 and R9 with a single resistor of 30 ohm. Redraw this circuit. So R10, here is R10, and now you can see R10 and R3 are now parallel to each other. They share the same two nodes, that is R3 and R10 is connected between node 1 and this node, and both share the same node, so they are in parallel. So what is their equivalent resistance? R3 is in parallel with R10, and R11 is the equivalent resistance of these two resistors, and R11 is calculated as 15 ohm. So what is the value of R11? It is 15 ohm. You can calculate it by yourself, that is R11. Now you can say R11 is in series with R7, and simply R12 is equal to 25 ohm. So R11 is in series with R7 and R12 is the equivalent resistance of these two resistors. R12 is equal to 25 ohm. Again redraw the circuit with in which you are going to replace R11 and R7 with a single resistor or resistance of value R12. Here is the equivalent circuit, and now R12 is in parallel with R2, which is both of them are 25 ohm. After evaluating their equivalent resistance, which is R13, we get R13 12.5 ohm. R12 is in parallel with R2 and R13 is the equivalent resistance of these two resistors. R13 is equal to 12.5 ohm, and redraw the circuit. Now there are three resistors R1, R13 and R8. All of them are in series with each other and their equivalent resistance is equal to 32.5 ohm. So R equivalent is equal to 32.5 ohm. The equivalent resistance of this network is 32.5 ohm. I hope you get it. You can see resistor R3 and R4 are in series with each other and their equivalent is simply 6 ohm. Just add R3 plus R4 and get their equivalent value, which is equal to 6 ohm, and we call this their equivalent as R9. Redraw the circuit and replace R3 and R4 with a single resistor R9. This is R9, which is equal to 6 ohm, and you can see R9 is in parallel with R5 and R7. You can see these three resistors share the same node, that is R7, R9 and R5 are connected to this node, and all of them are connected to this node as well. This is R7 which is connected to this node, and R10 is the equivalent resistance of these three resistors, and it is calculated as 2 ohm. So replace R7, R5 and R9 with a single resistance of 2 ohm. Let's redraw the circuit, and we redraw the circuit, eliminate R7 and R9 and R5 with R10. Now you can see R6 and R8 are also in parallel. Replace them with a single resistor. R11 is the equivalent resistance and its value is 8 ohm. Resistor R2 and R10 are in series with each other, and R11 is their equivalent resistance, which is equal to 8 ohm. Let's come to the next step. In this step, R8, R6 and R11, all of them are in parallel and their equivalent resistance is 1.6 ohm. R12, which is equal to 1.6 ohm. In this step, only two resistors are left and their equivalent is 11.6 ohm. And that's it.